I really enjoyed this school because it was the first time we could get in touch all together and to do real work all together. The first part was a wet lab experience that almost no one in the network of this ESRs had. So this was like something most of us really looked forward to. And it was, as expected, really interesting. We could dive into how things are done and how sequences are generated. And this is usually the start of our work.
So what I've really enjoyed about this winter school is that I've been exposed to a lot of things that I've never done before and didn't really know much about. So the first half, the wet lab, I mean, background, pure maths, have not had biology since about 9th class, have not been in a lab in a very long time, and only had a very rough idea of the actual process of getting my little DNA sequences that I then work on. So it was very cool to see how much work goes into the point at which then I get the data. And with regards to the dry lab part, the bioinformatics part, I've ended up in a group in a topic that I know absolutely nothing about. So it's sort of pushing at my boundaries, expanding my horizons in that sense, and that's very cool. It's enjoyable.
Well, this school in Bratislava has been a great opportunity to do the wet lab part, which is a way to understand how the data that we will work in these pangenomic projects are actually sequences, and how much work you have to do to sequence genomes. And it's been great to step out of my comfort zone and to work in the lab with great people supervising us, and but it's been fun.
So this workshop is really special because it combines both wet lab work and then software part. So it's very rare that you can apply data analysis on a data that you have produced yourself. And this is now the opportunity here for the students to see that whole pipeline from the beginning on. And for people with a little bit theoretical background, it's important to see how real software tools are working, so that you can see what kind of problems there are, and what are kind of the significant things one should contribute to, what are still open that nobody knows how to run a tool. There's no tool that you can run to convert this format into this format because there's some fundamental difficulties in doing that. So you kind of get that experience, and this is both important for the more senior researchers that are working on the overview of things, like thinking theoretically, okay, this can be done, but I don't need to do it. My PhD student can do it. But it's good to see yourself these things that can take a lot of time when you have to do it actually on the software level, that you get some feeling that how much work there is behind to actually solve some this kind of small software problem, for example. So yeah, this school gives new expertise for both the senior researchers and PhD students with different kind of backgrounds.
So this has been great because, as I said, my background is as a theoretical computer scientist. And although I have ended up working with people who really do real bioinformatics, and some of them actually use things I've designed, I'm really just bluffing. So I really don't actually know what's going on. So I can walk the walk, but I can talk the talk, but I can't walk the walk. And so I've been learning a lot about actually, you can sit down and if you type this, it actually builds you a pangenome graph. Well, that's very cool because I know about these things in theory, but actually finding out how you build these things in real life is great. Because usually the theorists, they sort of keep us locked away with our blackboards and we just design things and we never see how they're used. So this is, I can see, and so some of these data structures, I can say, I know the people who designed these, I know the people who wrote these things, and wow, you're going to do this with them. That's very cool. And you know, especially since this is biomedical applications, we're going to heal sick people. I mean, my mom would be super proud if I ever sit down and explain this stuff to her.
Well, I've been shown some useful bash commands. So that will definitely make my work slightly more efficient now. And I have been thinking about whether or not, so I'm in the haplotype group and I've had some thoughts as to whether or not this problem might, you know, in the sort of abstracted formulation also be related to what I'm doing. And I'm probably going to ask some targeted question to my PI after this school.
I think the first part of the wet lab might have changed what I would like to do after the PhD, because I really enjoyed and appreciate this part. So I might look forward to something that also gives some possibilities on a wet lab, and the part of groups working together to produce some results from the sequencing made me appreciate even more, like more working into groups compared to doing research more alone.